the 660-ton steel sphere located at the top of the 500-meter Taipei 101 is what protects it from typhoons and earthquakes. The fact that since its construction in 2004, the skyscraper has survived multiple strong typhoons and earthquakes, including the 7.4 magnitude earthquake in 2024, one of the strongest in Taiwan's history, proves that the sphere actually works. In this video, I'll explain how the tune mass damper in Taipei 101 works. This is, by the way, how the sphere is actually called. I'll also talk about other ways of protecting skyscrapers from seismic forces. In order to understand why the sphere is needed, you need to understand the geology of the place. Taiwan is located in the Ring of Fire. What is it? It's a zone around the edges of the Pacific Ocean, which contains 2/3 of all volcanoes in the world. Places like Japan and California are located in the Ring of Fire, and I think you know how seismically active these places are. Taiwan is also located in this zone, and it also gets a bunch of earthquakes. In addition to that, Taiwan gets a lot of typhoons, like in average 3 to 4 per year. So yeah, this is definitely not the best place for super tall skyscrapers. And this is actually the exact reason why this tune mass damper is needed. It's worth noting that the sphere is not the only thing protecting the skyscraper. Firstly, Taipei 101 was deliberately designed to be flexible. So when there is a strong wind, the skyscraper will sway and kind of bend a little bit. I think you've seen videos on the internet of swaying skyscrapers. Almost every skyscraper is designed this way, not only Taipei 101. So even though it looks scary, it's actually a good thing. It prevents the fracturing of the structure. Secondly, the foundation of Taipei 101 is reinforced with 380 piles, driven 80 meters into the ground. So even without a tune mass damper, Taipei 101 can withstand some strong typhoons and earthquakes. But still, this tune mass damper plays a crucial role in the protection of this building. It reduces the amplitude of vibrations, which, firstly, makes Taipei 101 even more stable, and secondly, it simply increases the comfort of the residents of the skyscraper, which is also important. So, how does the sphere work? Actually, the way it works is quite simple. It's just a pendulum that, by swinging back and forth, absorbs the kinetic energy of the skyscraper, reducing this way the amplitude of vibration. But there is one important thing to note here. Do you see these things? These are oil dampers. Without them, this pendulum will do more harm than good. If there were no dampers here, the pendulum will simply transfer kinetic energy back into the skyscraper, which will only make things worse. The skyscraper will just randomly sway. So these dampers are very important because they absorb the energy. Without them, this whole thing is useless. I also wanna note that Taipei 101 is not the only skyscraper in the world that has a tune mass damper. Actually, many skyscrapers across the world are equipped with it. Some of the most famous ones are Central Park Tower, 432 Park Avenue, Petronas Twin Towers, and many others. It's just that usually tune mass dampers look pretty utilitarian, so they're hidden from the eyes of regular people. But in the case of Taipei 101, they decided to make it a tourist attraction. And that's cool. Prior to that, most people hadn't even heard about tune mass dampers. But now, more people know about them, which is awesome. But tune mass dampers are not the only way of protecting buildings from earthquakes. There is one more way. Base isolation. I think you've guessed from the name that it has to do something with, well, base isolation. Indeed. In this case, the building, with the help of these lit rubber barons, is isolated from the ground. When there is an earthquake, these things, which are flexible, begin to flex and stretch, absorbing most of the energy this way and leaving the building virtually motionless. Many structures are base isolated, and not just skyscrapers, but also bridges and airport terminals. For example, one of the terminals at Istanbul International Airport is base isolated, and so are many other structures across the world. The goal of this video was, well, first of all, to explain how tune mass dampers and base isolation work. But the main goal of this video was to show how far we've come technologically in such a short time. Even a century ago, it would have been impossible to imagine that we will be able to build such tall skyscrapers in such seismically active places. But today, it's a reality. I don't think you're even gonna surprise anyone with that. This is why science and engineering are so cool. And with this video, I want to inspire more people to become scientists and engineers. Because thanks to them, people living in Taipei 101 and other seismically protected buildings now don't have to fear earthquakes. They are completely safe. All thanks to scientists and engineers.